You are welcome to today's lesson. From our previous lesson, we learned that to find the gradient m and the y-intercept c, the equation must be expressed in the slope equation form. That is, y equal to mx plus c, where m is the gradient and c is the y-intercept. Objective for the day. By the end of the lesson, the student will be able to find the angle of a straight line when the equation is given. To find the angle between a straight line and the positive x-axis, there are 3 steps we follow. Firstly, express the equation in the slope equation form. That is, y equal to mx plus c. The next is to find the gradient of the straight line. Then lastly, equate the gradient m to tan theta and solve, making theta the subject of the equation. That is tan theta equal to m. We equate tan theta to m because from trig we learned that tan theta is equal to opposite over adjacent. That is, change in y over change in x. That is why we equate tan theta to m, which is the gradient. And note that theta represents the angle we are looking for. Let's take our first example. Find the angle of the straight line whose equation is 3x plus 2y minus 1 equal to 0 mixed with the positive x-axis. Solution: 3x plus 2y minus 1 equal to 0. We move 3x and negative 1 to the right side of the equation. So that gives us 2y equal to negative 3 plus 1. We have to express this in the slope equation form by making y the subject. So we divide through by 2. And that gives us y equal to negative 3 on 2x plus 1 on 2. From our previous lessons, we learned that when you express an equation in the slope equation form, the coefficient of x becomes our gradient. Therefore, our gradient m is equal to negative 3 on 2. We then equate tan theta to negative 3 on 2. We are looking for theta. Therefore, we take the tan inverse of negative 1.5, and that gives us theta to be equal to 123.7 degrees. Therefore, the angle the straight line makes with the positive x-axis is equal to 123.7 degrees. Let's continue with these examples. Find the angle of the straight line whose equations are given mixed with the positive x-axis. And the first equation is y equal to 2x minus 1. The second equation is y equal to 5x minus 3. And the last equation under this section is 4y minus 2x plus 1 equal to 0. Let's look at the first one. The equation was y equal to 2x minus 1. The equation is already in the slope equation form. Therefore, we pick the coefficient of x as our gradient. Therefore, our gradient m is equal to 2. Then we equate tan theta to the 2. We are looking for theta, so we take the tan inverse of 2, and theta is equal to 63.4 degrees. The second equation was y equal to 5x minus 3, and that gives us 78.7 degrees. The third one was 4y minus 2x plus 1 equal to 0, and when you solve it, you are going to get 26.6 degrees. From the knowledge you have gained under this subtopic, try your hands on these examples. Our next lesson will be on finding the equation when the gradient and the point is given. Thanks for watching, and don't forget to subscribe.
So with example 1, if you want to find your answer using the calculator, this is how you do it. First, you must make sure that your calculator is in radian. Mine is in radian. This is it. So I'm going to change it to degrees. So we are going to work in degrees. So you first change your calculator to degrees. Now after changing it to degrees, now the first question, after solving, getting to the end part of your calculation, we have theta equal to tan inverse into bracket -1.5. So how do you punch it? Now we have tan here. We have tan here. So if I want tan inverse, I just click on the shift and then I press the tan inverse key. Now we have -1.5. So I have -1.5. Then I press equal to. This is what I'm going to get for an answer. Okay, so the value we had for the first question, what is the tan inverse -1.5? We had a -56.3. Now this is not the angle we are looking for to make with the x-axis. And so how do we get our positive angle? And so to get your positive angle, the value we had is less than, or it is not up to 90 degrees. And so the only way to get my positive angle is to add 180 to whatever answer that I'll get. If it is negative and it is not more than 90, if it is not more than 180, you are going to add 180. You are going to add, not subtract. We are adding 180 to get the value, the positive angle that makes with the x-axis. So we have -56. -56 is less than 180, so we are going to add 180 to -56. So when I add 180, which is plus 180, I'm going to get 123.69. So in one decimal place, I'm going to get 123.7 degrees, and that's for the first one. Now for the second one, you clear the same shift and turn. So the second one, we had our gradient to be 2, so I punch 2. Then equals, I'm going to get 63.4. 63.4, one decimal place. So the reason why we keep this answer is because it is already positive. So this is the angle it makes with the x-axis, positive. So you don't do anything. If it was negative, we are going to add 180. So now we don't do anything. We move to the next one, shift, and then turn to give us the tan inverse. And then the next gradient was 5. For example 2, II 5. So that one we are going to get 78.69. So one decimal place is going to be 78.7 degrees. So that's your answer. So if you move to the last one, which is when you make y the subject, you are going to get 2 on 4. So which is 0.5. Shift, turn, and we have 0.5, which we are going to get 26.61 decimal place, 26.6 degrees, 26.6 degrees. Okay.